in the sentence.
Hello children, you are welcome to this segment of the program, The Classroom in Your Home. It is mathematics time, and that means it is time to have some fun. Hi, I'm Uncle Agbaje. Today in mathematics, we will continue our work on angles between lines. Remember that last week we talked about the parallel line, the line that crosses parallel lines, which is called the transversal, and we're able to identify corresponding angles. Today's learning objectives: by the end of this lesson, you should be able to do three things. The first of which will be, you should be able to identify what we call interior opposite angle. Now, I don't want that name to scare you. Just wait till we get there. You should also be able to find missing interior angles. When you are able to identify them, you have to find the value. And finally, you should be able to find missing angles at a point. So drop your pens and drop your papers and listen attentively as Uncle Agbaje walks you through the processes. Now, in our last lesson, we taught you this song. Let's sing it again. There are different types of angles, but don't be entangled, no. There is corresponding and vertically opposite. Complementary 90, supplementary 180. 90, so 180. These are some of the angles that we taught last week. Complementary angles add up to 90, supplementary add up to 180 degrees. And now let's see how we can apply that knowledge today. Now study this diagram critically. In this diagram, A and B are on a straight line. This is the straight line right here, and this is the center of that angle. Now A on this side, B on this side, they form a semicircle, and because they form a semicircle, they are supplementary, which means that their sum will be 180 degrees. Now moving on. Now let us move angle A along this line. Now they are on a straight line, quite alright, and they are equal to 180 when we had A and B together. But now we don't want A on this side. Okay, note that when we add A and B together, we get 180. But we don't want A to be on this side, so let's move it to another point on the line. Now you see that angle A has moved to the right side. Now, as it is right now, A and B still add up to 180. If I still add A and B, they will still give you 180 because I did not change the size of A. I did not increase the angle. I just moved it to the right. So A plus B still gives us 180. But as it is right now, we can no longer say that A and B are angles on a straight line because B is centered around this point and A is now centered around a new point. So a semicircle drawn from here to here will have two centers, and that will not give you 180. It's not even possible. So A and B will give you 180, but they are no longer angles on a straight line because they are not at the same point. So what do we call A and B the way they are right now? Let's say the way A and B are positioned, we don't call them angles on a straight line. Rather, we call them interior opposite angles. Say that with me: interior opposite angles. Interior opposite angles. And it is quite easy to see why they are called interior opposite angles. First, they are inside what looks like a room. Both of them are inside and they are facing each other. So they are interior and they are also opposite. So when you remember inside, interior, then you remember the angles. Now, A and B are interior opposite angles. The interior opposite angles can be recognized with the letter U. Don't forget that I try to give you a letter for each type of angle. For corresponding angle, you can recognize it with the letter F. For alternate angle, with the letter Z. For vertically opposite, with what letter? With the letter X. So now for interior opposite angles, you can recognize it with the letter U facing any direction. That means in this case, this is your U. See? Sometimes the U can be like this. Sometimes it can be like this. Sometimes it can be like this. But as long as the lines of the U are parallel to each other, then the angles inside are always going to give you interior opposite angles. Now, interior opposite angles, don't forget that A and B, when we add them together, we'll get 180. So interior opposite angles will always give you 180 degrees. That means that they are supplementary. So I'll just go over the process again. We started with angles on a straight line beside each other. You know that that one will give you 180. Then we moved one of them to another point on the line to form a U. They will still add up to 180, but they are no longer angles on a straight line. They are now found inside a U, and we call them interior opposite angles. So let's look at some application of this in problem solving. The example says, find the value of the angle K in the diagram below. Of course, you can see now that 65 degrees is on this side and K is on the other side, and easily you can identify the U. Okay, so the lines are parallel and you have the U, and the angles inside the U are interior opposite angles. Now mind you, interior opposite angles are not equal. They are supplementary, which means that they will add up to 180, as we will see. Now let's try and solve this. As I have said earlier, angle K and 65 degrees are interior opposite angles. This is the U, and both of them are inside the U. Then that means that they are supplementary, or they are supplements of each other. And what that means is that if we add them together, we will get 180. As you can see, angle K plus 65 degrees must give us 180 degrees. So I'll just give you like 10 seconds to solve this. You know how to do it. So take your time. You should be having your answer right about now. Okay, so let's just run through it. So now we take 65 degrees to the other side. Remember, we have to take all the numbers to the right side where we have numbers that are the same. Now plus 65 will become minus 65. So you have 180 degrees minus 65. And then you can finish it up by bringing the K down and doing the subtraction. You'll get 115. And that means that K here is 115 degrees. Easy peasy for you, my friend. Let's just take a look at another one. Now here we're asked to find the angle M and angle N. And it is easy to see that angle M and angle N have what relationship? Can you see the U? Because I have seen the U. If this is what you are saying, my friend, then you're correct, because the U is now facing sideways, from like a C. Now, M and N are interior opposite angles, but we don't know M, which means that we can know N. So we have to try and see if there's another way we can find one of these angles. Look to the other side. You see 108 degrees. Now, remember, what is the relationship between N and 108 degrees? What shape do you see? They are corresponding angles, because this is the F. One line of the F, second line of the F, and then the line joining them. The F is facing downwards like this. So which means that this angle and this angle are corresponding and they are equal. So let's see. So N and 108 degrees are corresponding angles, and that means that they are equal. So N is equal to 108 corresponding angles, because this is the F, like I have said, F facing downwards. Now, since we now know N, we know that N and M are now interior opposite angles, because we have a U that is facing the right. So N and M are interior opposite angles, therefore they are supplements of each other. So we now use this knowledge that N is 108 degrees to find M. So now N is 108 degrees and M is the supplement of N So what do? We had n and m together, we get 180 degrees. Now we replace n because we know that n is 108. So instead of writing n, we write 108. Then we'll bring down m and we'll get 180 degrees. Now you can solve this quickly in 10 seconds. And you should have moved that number over to the other side. And you should be getting your answer right about now. Let's just see how it's done. See, now m is here alone. 180 will go to the other side and it will become minus 108 degrees. 108 degrees to the other side, minus 108 degrees. Now you do that subtraction and you will get 72 degrees, telling us that this is 72 degrees. Important point that we have learned here. Interior opposite angles are always adding up to 180 degrees. Now let's take a look at something different. When a line rotates in a circle, we have done this before, it goes in a circle, the bottom is fixed at the center and it keeps going. If it starts from here, by the time it comes down, back again, that's 360 degrees. Another 360, 720, another 360, another 360. Every time the line goes around the circle, we say it has traveled 360 degrees. Now, therefore, if we add all the angles together around this point, everything must give us 360 degrees. I want you to take note of these aspects. Now, imagine this line is going to start moving right now. I'm going to tell it to move. It will move. So let's see how it goes. So now it has moved, and this movement, this small movement, is just 45 degrees. And I'll tell it to move again. Another small movement from here to here is 30 degrees, not from the starting point. Let me put S here for starting point. So now from here to point 1, I get 45 degrees. From point 1 to point 2, that's just 30 degrees, little movement. Let's see how far it will go the third time. Now let's call this point 3. Now it has moved 90 degrees from point 2 to point 3. Let's see again. Now from point 3 to point 4, it has moved 70 degrees. Now from point 4 to point 5, it has moved 65 degrees. And now back to the starting point, it has moved 60 degrees. When we had all these little movements, everything must give us 360 degrees, as you will see. Say 45 plus 30 plus 90 plus 70 plus 65 plus 60. Everything will give you 360 degrees. Take it again. 45 degrees plus 30, that's 75 degrees. Plus 90, that is 165 degrees. Plus 70, that's 235 degrees. Plus 65, that is 300 degrees. And then plus 60, that is 360 degrees. Confirming that all the angles around a particular point must give us 360 degrees. Let's see how we can use this to solve problems. This example says, find angle A in this diagram. Now we observe that there are many angles around this particular point. See, your first task is always to identify the center, the point. This is the center, this is the point where you have all these angles. So what you want to do is that you identify all the angles. Here I have 18, I have A, I have 32 degrees, and I have 205 degrees around that point. So I'm going to add all of them together, knowing fully well that if I had all the angles around a point, I will get 360. So I bring all the angles together and equate them to 360. That means that 18 degrees plus 205 degrees plus 32 degrees plus that angle A that I do not know, if we had everything together, they are around the point. So they must give us 360 degrees. Our next task is just to solve this equation. So I'll just begin it for you. So now I've added all these numbers for you. 18 plus 205 plus 32, that will give us 255. So you just complete it. You have 10 seconds. You should begin by moving your number to the right side. And then remember to change the sign. Find the difference. And your answer should be coming up right about now. So I've taken 255 to the right side. So on the right side I have 360 degrees minus 255 degrees. Now let us subtract. We will get 105 degrees, my friend. Telling us that this angle right here has to be it must be 105 for everything to be 360 degrees. Let's take a look at just another one. Here this says you should find the value of A again in this diagram. But now we have several angles at the center of that diagram, and this is the center. I have 2A, I have 5A, I have A, then I have 4A. 4 angles around that point. Now what do we know? We know that if we had all the angles together around the point, we must get 360 degrees. Good job, you. So let's see how this is done. So I'll just add all the angles. Like I always say, do not be afraid of the numbers. Stick with what you know. And what you know is that if you add all the angles around a point, you will get 360. So add all the 4 angles around that point. A is there. 2A is there. A is there. 2A is there. 4A is there, 5A is there, you have 360. Now you discover that all these ones are algebraic terms. They have A, so you don't need to move anything to the other side, because on that side we have just numbers. So leave all the algebraic terms on this side. You can add them. 1 apple plus 2 apples, that's 3 apples. 3 apples plus 4 apples, that's 7 apples. 7 apples plus 5 apples, that's 12 apples. So now you have 12A. On the right side of the equality sign, you have 360 degrees, my friend. So I'll just leave you to solve this in 10 seconds. Are you going to move anything to the right side? Nah, I don't think so. So what you want to do is that eliminate the coefficient to remove the number from the A. How do you do that? You divide by the coefficient to remember. Your answer should be coming up right about now. Let's see how it goes. So we will eliminate the coefficient of A. That's the number beside A. And to get rid of that, you just divide by that number. Let's divide by 12 on the left. Now, whatever you do on the left, you have to do on the right side as well. So now in this case, 12 cancels 12 because 12 goes here 1, 12 goes here 1. Now 12 goes in 360 30 times. So on the left, we are left with A. And on the right, we are left with 30 degrees. I believe that this is the answer that you got, my friend. We have come to the end of the lesson. I believe that you enjoyed yourself. Now, I'm going to give you 1 minute to copy the assignment that will come up on screen. Practice. Use all the knowledge that you've acquired in the past couple of lessons and find the missing angles in this diagram. Here you have interior opposite angles. Angles around the point, and interior opposite angles. Practice, and I will be on hand in the next lesson to guide you through the correction. You have 1 minute to copy this. Begin. Alrighty then, we have indeed come to the end of the mathematics class. I will now hand you over to Uncle Popo for the general studies lesson. Till I come your way next time, remain wonderful mathemagicians.